Good morning, everybody. Good morning, good afternoon, good evening, depending on the time you're watching this video. And today we're going to focus on how to create an animation simulation, okay, based on the clock project in the Inventor. And you need to open the assembly drawing in the Inventor first. If you make it this far and finish the entire clock with all the gears, okay, the way it's instructed, and they added everything using constraints and check it out. And if you rotate the second arm the way you see right now, all arms are supposed to rotate proportionally slower than minute arm, much slower than second arm, and the hour arm is apparently a whole lot smaller than minute arm. So, and there is a mathematics behind that, proportions and mechanical advantage and principles of engineering. And now I'm turning everything counterclockwise. Normally, entire clock works in clockwise rotation is designed for that. And just to demonstrate that this is something you need to check it, you make sure that all of the gears and the axles are constrained properly, and at this point you should have everything working. Please use variety of different colors, okay, to make the entire clock more appealing. There are a number of things you repeated, and one of them is your virtual controls using your mouse. Mouse is extremely important in these operations. I know a lot of people do not use mouse, and you have probably the role model of all of those people. But I insist asking you to bring and use your own mouse with you, carry it with you, because it's going to make things a whole lot different and far better for you, and it's going to increase your productivity and accuracy as well. So the fact that you have a touchpad on the laptop should not refrain you from using a mouse. Mouse is absolutely necessary if you're pushing the limits of your laptop and the software that you have. Now, having said that, now today we are focusing on, and you are going to be accomplishing a simulation. And to simulate, there are multiple ways of simulating. Okay, I'm going to only demonstrate one way of doing this. Okay, and we may have to be, as we have time, we can focus on the other ways to simulate this the clock, entire clock. Everything has been constrained. If you notice it, we did not use the joint option of constraining or assembling parts. We use only constraint. Future, I want you to notice that there is a difference between joint and similarities also, and constraining the two parts together. We use only the constraints, okay? And one of the things you would like to do, okay, change your point of view by just simply making it a little bit smaller, and perhaps pressing your thumb wheel, okay, and centering. I'm pressing the thumb wheel, I'm moving and panning down, and perhaps you should be using your orbit command to focus on where, look down from 12 o'clock, okay, and then zoom in a little bit better. There it is. And press the right mouse button, and let's get out of the orbit command. Orbit command is very useful command, and what I'm trying to do is create another constraint. And that particular constraint, I'm just going to choose it, perhaps the angular constraint. I'm going to go with the angular constraint. So in the angular constraint, I'm going to zoom in. I want to show you the flat surface. Only the flat surface on top of the second arm will be selected. Keep your cursor on the flat surface and click on it. Okay. Now you need to select a different flat surface above the clock, the 12 o'clock. Okay, position and click on it. Now, if you cannot find a flat surface, this is going to be a problem. You have to create one, obviously, later on. So this way, you generate it, okay, an angular constraint. So I'm looking here for the angle of, say, 1200 degrees, okay? And I'm selecting the first option, okay? I'm going to apply it, and I'm going to get out of this scene, all right? And I'm going to change the view. It immediately corrected to 1200. Basically, it divided the 1200 by 360 degrees and find out where the clock supposed to be, the second arm supposed to be. Now, second step is you have to focus. You have to focus where the new constraint is located on the browser, on the left. The view constraint is supposed to show up at one point, okay? And as soon as you find out, and I find out, I'm going to share it to you. So this is the second folder on the browser. I just find out, I'm sharing with you. The first folder is model states for states, so colon master. And second folder says relationships, and when you click on the plus button next to it, that folder opens up and shows all the files inside. And last file, that what we accomplished recently, Angular. So if you click on that, it shows you the 1200. You can modify that number if you want to. If you click with the left mouse button, if you click with the right mouse button, it will give you a drive option. Click on the drive option, okay? And you can modify where it starts. So say started from 0 degree and will end 1210, okay? And you want to play this and to see how it's going to work out. Now, play it. And you're supposed to see all of the gears are rotating, okay, at their own rates, predetermined rates. Minute arm is rotating at the same rate mechanically that we set up. Our arm is also gradually started rotating, okay? So this is good, but you don't want to play it backwards. Okay. And one of the things you can do, you can just simply change the angle of it and be able to have a better view of the gears in the back and the front plate, okay? And one of the things, other things you can do, just go to and maximize it, okay? Now, before we start going further, you could change the end of the degrees, okay? And you can increase the pause and delay over here on the top. Also, you can click on this record, and that will give you an access to recording as a Windows meta file, Windows movie file. Windows movie file is very native file of all Windows operating systems. So this is really convenient file type that you can just simply carry it to your own personal laptop and double click on it, and you can play it on the desktop to show your parents, to show your mom, dad, and your friends and your professors, college professors, perhaps admission committees. This can become a very valuable part of your engineering portfolio. If you want to send it to, make sure you put your name on it. That's another thing. I wrote Fairfax Industries at the end. That's my logo. You can rate your name on it, first name, or last name. Come up with your own logo, okay? But that's very important. It's proof of your work that you have done it. It's not copied from somewhere else. So I'm going to save this in a particular location. That's extremely important, that I usually either go to OneDrive, but it's limited space, so I don't want to go to OneDrive. I have a very limited space in left over there. I'm going to go to Google Drive and distant learning and and STEM engineering. In the STEM engineering, within the STEM engineering, we can access the mechanical clock. Gears of a clock. Okay, so this is where I am saving. Okay, I'm going to call this gears of a clock in capital letters. Okay. Again, this is an intellectual property. You designed it. It is yours. Put your last name. I write my last name. Gears of clock by again. This is my design. I have been using this for 17 years, and so I created this lesson myself, and so I'm putting my name on it. But you also do it. You're my student. You're allowed to. I give you property of this assignment. Okay, so put your last name. Save. I want to save this file now. Okay. And you can see it on the dialog box. You can see the image size. Okay. And there's an internet version. It's a broadband version. Internet version will be 56K modem. Intranet version 100. These are the higher. So let's go to OK button, and now let's play this, and it's going to be recorded as it plays. Now every rotation of the second arm is 1 minute, and you can see that it is realizing. And it's pretty realistic because I can see the marks in 1 minute marks. It follows, the minute arm is following the 1 minute marks every time. Second arm makes the 360 full rotation. Okay, and thank you very much for your time for today. Okay, and next class we're gonna focus on something else on the next video. Have a great day. Bye.